Hi everyone, this is Dr. Nally. In this chapter, which is chapter 8 in the Zumdahl book, we will be discussing an introduction to several of the concepts that will be important to understand chemical bonding. This discussion we will continue in chapter 9, the following chapter, to talk about more advanced topics. But first I want to kind of introduce the idea of chemical bonding and talk about some of the topics that we will discuss in this chapter. So first off is just what is chemical bonding? Okay, what is a chemical bond? Then to understand that concept, right, at a very superficial level, you need to understand that as far as we know right now, there are about 118 elements that have been discovered or synthesized, but we know of millions of compounds, which are things that are formed by combination of these 118 elements out there. So there's a lot more compounds than elements. Now, if there are a lot more compounds than elements, we need to obviously understand how these compounds are formed. Okay? Now, as we discussed in the chapter on energy and thermochemistry, chapter 6, the reason why something happens is because the process takes that sample of matter from something that is high energy to something that is lower in energy, okay, which we call more stable, right, energetically. So in this sense, we can imply that molecules, okay, this collection of atoms that are held together are somehow more stable energetically than individual atoms are, okay? Our goal in this chapter is really to understand how these atoms are held together. Why is it that when the atoms are together, they become more stable in comparison to when they're not together, when they're separate? So the concept that we develop to understand this is what we call a chemical bond. So we understand that the atoms must be held together by something that by a force that's really strong. This force is what we call the chemical bond. Now you'll see when we get into the chapter, we'll talk about two types of compounds. We'll talk about ionic compounds, which if you remember we talked about this in general. These are compounds that are formed by ions that come from a metal and another ion that comes from a nonmetal. We'll also talk about covalent compounds, which are compounds that are formed from two nonmetals that happen to share their electrons. So we'll talk about the details of each of these bonding. Now, the question that I always kind of put up at the very beginning of each topic is why do we need to study this topic? And for chemical bonding, it's fairly easy to see. The properties of a molecule come from, obviously, the properties of the atoms that make up that molecule. So if a molecule is made out of sodium and chloride, we need to understand the property of the sodium and the chloride atoms to understand how sodium chloride behaves. But we also need to understand what is it about the bond, the force that's holding the sodium and chloride together, sodium ion and chloride ion together. What is it about that bond that makes sodium chloride behave the way it does? Okay, so that's the reason why we want to study chemical bonding. Once you understand the idea of chemical bonding and how to make certain calculations with it, you'll be able to answer questions that I list here and a lot more others. For example, we just talked about sodium chloride, which is table salt. Now we know the formula is NaCl. Why isn't it NaCl2? Why isn't it Na2Cl? Or some other combination of Na and Cl? Why must it have one Na and one Cl? Why do compounds formed by metal and nonmetal, an ionic compound, why do those compounds tend to dissolve very easily in water and be able to conduct electricity? There's something about the bonding, the force that's holding them together that makes them do that. Why is something like methane, CH4, we know this molecule, seen them a bunch of times now. Why is the formula CH4 not CH3 or CH2? We'll talk about that some in this chapter, some more in the next chapter. Why are covalent bonds weaker than ionic bonds? What is the reason for that? What is it about the force that's holding atoms in a covalent bond that's different than the force that's holding atoms in an ionic bond, or ions in an ionic bond? Why does nitrogen in its elemental form is a diatomic gas as opposed to just a nitrogen atom? And there are a lot of other questions you can ask and answer once you understand some of the basic concepts associated with chemical bonding. So the goals, there are many goals in this chapter and in this topic. You want to be able to understand, first off, what is the main difference between an ionic and covalent bond. Okay, what is it that we call an ionic bond? What is it that makes something called an ionic covalent bond? You have to understand how to draw compounds and molecules. As you'll see, we'll spend quite a bit of time talking about this using something called the Lewis dot symbol, or something called the Lewis structure. You have to understand how to draw resonance structures. This is especially important if you're planning to continue on to organic chemistry. And you have to understand this concept of how to pick the major resonance contributor when you're presented with a series of non-equivalent resonance structures. And we'll talk about the concept of formal charge and how we can use it in that context of picking a major resonance contributor. You have to understand how to apply something called the VSEPR theory to predict what simple molecules look like and whether they're polar or nonpolar. And lastly, you want to be able to understand and use the concepts you learn in this chapter to calculate how strong an ionic bond is, and then to use the strength of covalent bonds, which we call covalent bond enthalpies, to calculate reaction enthalpies, the same type of reaction enthalpies that you calculate in the thermochemistry chapter. I kind of see this chapter as being divided into two big topics, ionic and covalent bonds, with most of the concepts discussed pertaining to the covalent bond and covalent molecule type discussion. We'll discuss some of these topics here. Lattice energy, Born-Haber cycle, those are related to the ionic bonds. And then the rest of these guys are all related to covalent bonds. You want to kind of put this in, organize this in your head, in your notes, so that you understand when I'm talking a particular topic, what is that, where does it belong, okay? So here's the topic listed more in a kind of, one by one, step by step. We're going to go through first ionic bonds. Then we'll spend the rest of our time talking about covalent bonds, Lewis structure, resonance structure, VSEPR theory, and then reaction enthalpy. I want to end here by saying that this topic doesn't end in this chapter, this chemical bond topic. We're going to continue to talk about more advanced theories for chemical bonds, because the theory we use in this chapter, which is the Lewis theory, turns out to be fairly straightforward, simple, doesn't quite represent molecules in the best, in the whole sense of the word molecule. We want to talk about other theories that people actually use in practice to kind of think about how molecules and how molecular properties come about. And that's going to be in chapter 9.